a table containing the homologous series, general molecular formula, and the functional group. Master this, and you have organic chemistry at the tip of your fingers. Let's go. So the first homologous series we are going to look at is the alkanes. The alkanes. What is their general molecular formula? CnH2n plus 2. What is their functional group? The alkanes contain single covalent bond, all true. Then the second one, the alkenes. The alkenes, they have the formula CnH2n. They are 2 hydrogen less than the alkanes. So how do we know them? They are made of carbon-carbon double bond. They contain double bond in between the carbon atom. So whenever you see an organic compound that has a double bond, mind you, that is an alkane. Okay, the next one, the alkynes. The alkynes. Now, you have the formula CnH2n minus 2. This one is 4 hydrogen less than the alkanes. Now, what is their functional group? How do you know them when you see them? They carry triple covalent bonds between 2 carbon atoms. So whenever you see any organic compound with triple covalent bond, that is an alkyne. The next one, the alkanols, also known as the alcohol. Now, the alkanols, what is their general molecular formula? CnH2n plus 1 OH. Now, CnH2n plus 1 is for the alkyls. The alkyls are 1 hydrogen less than the alkanes. So, the alkane, whenever you see an alkyl group with OH group attached to it, that is an alkanol. So, the functional group of the alkanols is the OH group. Remember, this dash is showing a covalent bond. You must add it whenever you are trying to show a functional group. Then we go to the next one. The alkanoic acids. They have the formula CnH2n plus 1 COOH. That is an alkyl group that carries COOH. Is an alkanoic acid. So their functional group is COOH. The next one, the alkanoates or the esters, they have the general molecular formula CnH2n plus 1 COO CnH2n plus 1. That is 2 alkyl groups attached to the COO. So the functional group of the alkanoates is COO. Why do I have covalent bonds attached to the carbon and to the oxygen? That is because an alkyl group is attached to the carbon and another alkyl group is attached to the oxygen for the alkanoates or the esters. Now the next one we are going to look at is the alkanals. What is their general molecular formula? CnH2n plus 1 CHO. So they have an alkyl group attached to a CHO. Hence, the functional group of the alkanals is CHO. Okay, so the next one, alkanones. Now, the alkanones, they are very simple to identify. What is their general molecular formula? The alkanones seems to look as the alkanoates, but they are not the same. The alkanones have just CO, while the alkanoates have COO. Then in the alkanones, we have two alkyl groups attached to the CO, one to the carbon and the other alkyl group to the oxygen. Hence, the functional group here is CO. It has two bonds as well, one to the carbon, one to the oxygen, so that the alkyl groups can attach. Okay, the next one, the alkoxy alkanes, which we also call the ethers. We have two alkyl groups attached to an oxygen atom. So we have CnH2n plus 1 O CnH2n plus 1, where the O is now the functional group. So the functional group of the ethers or the alkoxy alkane is an oxygen atom with two bonds. Okay, the next one and the final one we will be looking at is the amines or the amino alkanes, as the case may be. So we have the amines. In the amines, we see an alkyl group attached to an amino group. So we have CnH2n plus 1 NH2. So the functional group will be, drop the functional group in the comment section. Hope you enjoyed this class. Don't forget to like, comment, subscribe to my page. Turn on your notification button for my next video, which is going to still be on organic chemistry and very interesting. See you in my next video. Bye. Thanks for watching.